polynomial division and the division algorithm. The division algorithm. I was pausing to let you read this really quickly. So the division algorithm pretty much just uses a lot of math terminology to state something that you learned in maybe the 3rd grade or something. Your polynomial is equal to whatever you get as your quotient multiplied by the divisor. That's what's on the outside. This is what goes on the top when you divide, plus the remainder. So for example, way back in the day when you had something like 13 divided by 8. 8 is your divisor. 8 will go into 13 one time. 1 is your quotient. 1 times 8 is 8, and then you're supposed to subtract. And 13 minus 8 is 5. 5 is your remainder. So your number 13 is equal to the quotient, which is 1, times the divisor, which is 8, plus your remainder, which is 5. 8 plus 5 is equal to 13. That's all this is telling you. Alright? Now look at zeros and linear factors. The number k is a zero of the polynomial if and only if the linear polynomial x minus k is a factor of p. In this case, p of x equals q of x times x minus k for some quotient polynomial q. Oh my goodness, that's a lot of math terminology. What exactly does that mean? Well, let's go back to these numbers over here. When you divide 8 into 13, you got a remainder of 5. That means 8 is not a factor of 13 because you didn't get a remainder of 0. What if you were to divide 8 into 16? 8 will go into 16 2 times. 2 times 8 is 16. When you subtract, you get 0. 8 is a factor of 16 because when you divide it, you get a remainder of 0. That's pretty much what all of this is saying, as well as if you multiply your quotient by your divisor, you should get the number that's on the inside. 2 times 8 is 16. That's what this is saying here. Your quotient times x minus whatever this number is will equal your polynomial, which would be inside the division symbol. This also means that k is a solution of the polynomial equation p of x equals 0. And if p is a polynomial with real coefficients, and if k is a real number, then k is an x-intercept of p. This is what that means. If you divide x minus some number into a polynomial, and you get a remainder of 0, then that number, the x minus some number, that number is a 0 of your polynomial, and x minus that number is a factor of that polynomial. The remainder theorem. If the polynomial p of x is divided by x minus k, the remainder is p of k. That is, p of x equals q of x times x minus k plus p of k. That's pretty much what we were talking about up here. And this one. The remainder theorem is taking that a little bit further. If you divide some number, this is some number, x minus that number, into your polynomial, then whatever remainder you get is the same thing as if you were to plug that number into your polynomial. Divide the polynomial 9x to the 5th minus 3x to the 4th, blah, 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 by the polynomial, all this one. Okay, 3x squared plus 2x minus 1 divided into 9x to the 5th. You need to make sure you're not missing any terms. I always look at the exponents. 5, 4, 3, 2, 1, 0. If I didn't miss any, then I'm not missing any terms. Alright, what do you multiply by 3x squared to get 9x to the 5th? You're going to need a 3x cubed, right? 3x cubed times 3x squared is 9x to the 5th. 3x cubed times 2x will be 6x to the 4th. And 3x cubed times negative 1 is negative 3x cubed. Remember, the next step means you're supposed to subtract. Well, what I like to do is just go through and change all the signs, because that's what you're doing. You're distributing a negative. Now we do that subtraction. This is 0. Negative 3 and negative 6 is negative 9. And 6 plus 3 is positive 9. Then I bring down my next term. What do I have to multiply by 3x squared to get a negative 9x to the 4th? I will need a negative 3x squared. Negative 3x squared times 3x squared is negative 9x to the 4th. Negative 3x squared times positive 2x is a negative 6x cubed. Negative 3x squared times negative 1 is positive 3x squared. Next, I subtract. This is 0. This is 15x cubed plus 4x squared, and I bring down the minus 8x. What do I need to multiply by 3x squared to get 15x cubed? I need a 5x. 5x times 3x squared is 15x cubed. 5x times 2x is 10x squared. 5x times negative 1 is negative 5x. Then I subtract. This is 0. 4 minus 10 is negative 6. Negative 8 plus 5 is negative 3x, and I bring down the plus 14. Now what do I need to multiply by 3x squared to get negative 6x squared? I will need a negative 2. I'm going to transfer that last line up here. Okay, so negative 2 times 3x squared is negative 6x squared. Negative 2 times 2x is a negative 4x. Negative 2 times negative 1 is a positive 2. Then I subtract. This is 0. This is 1x, and this is plus 12. So my quotient is 3x cubed minus 3x squared plus 5x minus 2. This is my quotient. This x plus 12 is my remainder. Normally you would write this as, you put plus and then write it over here, but I don't have enough room. So plus x plus 12 over your divisor, which is 3x squared plus 2x minus 1. So if you wanted to check this, it would take a little bit of work, but you would take all of this, all of the quotient, multiply it by all this on the outside. Once you get that answer, you would add x plus 12. And if you did all of that, then you should get everything that's underneath this division symbol. Okay, look at the caution at the bottom of the page. Although polynomial long division is a straightforward process, one common error is to forget to distribute the negative sign in each step as one polynomial is subtracted from the one above it. That's what I did here with all of these red sign changes. I distributed my negative. Just be really, really, really careful that you pay attention to this caution method. Message, not method. Compare the division of negative 3x cubed, all this stuff, by x minus 3 below, using long division on the left and synthetic division on the right. Okay, so what they did was take this polynomial, divide it by x minus 3, and they got this answer. Look at the synthetic division. That's what this one is over here. You take your coefficients, negative 3, 7, 8, 1, negative 3, 7, 8, 1. You take the opposite of this number, so that would be 3, and you do synthetic division with that. So what you do is you bring the first one down, then you multiply. 3 times negative 3 is negative 9. Then you add these. 7 and negative 9 is negative 2. And you keep doing that. Multiply, add, multiply, add, multiply, add. So 3 times negative 2 is negative 6. 8 plus negative 6 is 2. 3 times 2 is 6. 1 plus 6 is 7. Notice how this is your remainder. This is your remainder. So if you wanted to convert this to the actual answer, you want to decrease your exponent by 1, which means this will become x squared. So that's 2, 1, 0. So you would have negative 3x squared minus 2x plus 2 with the remainder of 7. So 7 over x minus 3. This would be your quotient plus remainder. For each polynomial below, determine if the given k is a 0. If not, determine p of k. Really, all I want you to do is divide this polynomial by x minus 2. If you do, that'll tell you whether or not this number is a 0 of the function. It will also tell you what p of that number is. So for a, we're going to use synthetic division. We're going to put 2 on the outside. I write it a little bit differently than the system does. Look at your exponents, 7, 6. We're missing 5 and 4. 3, 2, 1, 0. So we're just missing 5 and 4. So we're going to put 4, negative 7. This is where we're missing 5 and 4. So I put 0, 0, and then negative 5, and then 1, and then negative 8, and then 4. Okay, bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. So in this one, k equals 2 is not a 0, and p of 2 is equal to the remainder, which is 16. Let's try the next one. So for b, we're going to divide 3 into, I'm going to have to try to write smaller this time, 4, 3, 2, 1, 0. We're not missing any terms. So negative 3, 10, negative 5, 7, negative 3. Bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add. This time we got a remainder of 0. This means 3 is a 0 of that function.